All right, so this is a follow-up to the video we saw in class about ugly people. And do ugly people get paid less?
Okay, I'm a cheerleader now. UGLY, you ain't got no alibi, you ugly.
That's what we're talking about.
You ugly.
Is you ugly? Not you in particular, but just people in general. So let's go ahead and write out the model that we want to look at. So we want to ask, do ugly people get paid less? So we want to, our outcome is wage, their wages they get, equal beta naught. Okay, and now we need some measure of ugly. Okay, or whatever that might be. Okay, now we also want to think of what are some other things that might affect one's beauty and one's wage. So we want to also include those. Okay, so I'm just going to type in capital B, capital X plus U, and that's going to be different X's that we can include that we want to control for. All right, so that's our base model. All right, so let's go ahead and look at the data and see what we have. So here in our data set, we have wages, we have experience, we have a looks, which goes on a scale from 1 to 5. We have a dummy variable if the person's in a union, a dummy variable if they're in good health, a dummy variable for if they're black, a dummy variable for if they're female, a dummy if they're married, a dummy if they're south, if they live in a big city, if they live in a small city. The omitted group here is a medium-sized city is a third option. One if they're in the service industry, the experience squared, and education. Okay, so the base model, we'll just go ahead and run something, is let's go ahead and look at wages and looks. Okay, I'm copy those, put them into a new sheet. I can run a regression. Not solver. Ooh, bring back bad memories for many of you. Regression, click OK. My Y range is going to be wage. My X range is going to be looks. I'm going to include the output range, put it right here, and I had labels. I click OK. So here's what it tells me. All right. So this is just a base model. In a sense, looking at our base model, I've estimated wages not on ugly, but on looks. And I actually don't have a beta X there. That's just the model I estimated. All right, something like that. So now let's go ahead and interpret the different variables we have. So the intercept tells us the average Y when X is 0. So this is the average hourly wage when looks are 0, and that number is 5.11. Okay, so people with 0 looks get on average $5.11. Now, how do we interpret the variable for looks? Well, this tells us for each unit change in looks, wages will change by 37 cents. All right, so if you go from a 1 to a 2, you should expect your wages to increase by 37 cents. If you go from a 4 to a 5, your wages should increase by 37 cents. All right, now the next question is, well, is that number different from 0? All right, so the key here is our null hypothesis is always, or not always, but generally speaking, is that beta 1 is equal to 0. That's our null. All right, and our alternative hypothesis is that beta 1 does not equal 0. Okay, so that's what the null that we're going to test. So let's look at our data. We find that our t-stat is 1.9. All right, so remember 1.96 is the magic number. P-value needs to be less than 0.05. So here at the 5% two-tailed test level, we failed to reject the null. So we failed to reject the null, therefore we conclude that beta 1 could be 0. Meaning that as looks increase, that has no correlation with your wages. All right, so we failed to reject the null and conclude that if beta 1 is 0, looks can change and that will not change wages. All right, but this might be a little naive of a model because as they talked about in the video, it's not being a unit change in looks, it's ugly people compared to better looking people. So now I need to go back to my data and change some of my variables. Okay, so I want to add a variable below average and a variable above average. Now I'm going to create a dummy variable here. So I want this to equal, if looks is below 3, give me a 1, if not, give me a 0. Okay, so that tells me if looks is a value of a 1 or a 2, then that person's below average, where 3 is being defined as average. Okay, for above average equals if looks is above a 3, give me a 1, if not, give me a 0. So I've created a dummy variable for two different groups. I've taken a single variable, which is a count variable from 1 to 5, but because going from a 1 to 2 may not be the same as going from a 3 to 4, we might think it might be better to include dummy variables. So now we have below average and we have above average. All right. And so one thing to note is we don't actually have average, and that's because when we go to our dummy variables, we're always going to compare it to an omitted category. And that's where we need to leave out one of these groups. Secondly, is I actually want to create a variable log wage, which equals to the log of the wage variable. So in dealing with wages, it's almost always a great idea to do log wages. All right, so I'm going to copy this and below and above average. And when I paste them, I can't paste directly, so I have to go File. I'm going to paste, well, not that way. I'm going to go Home. I'm going to paste as a value. So rather than these equations, those are now values. Okay, I go Data Analysis. Before I do data analysis, let's look at our model. So my model no longer is looks. Now my model is below average plus beta 2 above average. All right, so now what I'm going to interpret as beta naught is the average y when all x's are 0. So beta naught is the average wage when you're not below average and you're not above average. Therefore, it's the average wage of people who are just average looking. And that's a meaningful interpretation. Beta 1 is the change in wage for a below average person compared to the omitted category, which is average. And beta 2 is the change in wage of an above average person compared to someone who is just average looking. So I now run this model. I get this. And now, let's go to my interpretations again. So the average wage in log points of someone who's average looking is is 1.69 log points. The average wage, or the change in wage of a below average person compared to an average person is 21%. And the change in wage of an above average person to an average looking person is negative 4.5%. So again, because we have log wage, we interpret these as percent changes in y. Now the question is, well, is that number different than 0? Our null hypothesis is beta 1 0. Well, here we test our null hypothesis and we notice that our t-stat is really negative and large, and therefore we reject the null, meaning that we reject that it's 0 and conclude that it's not 0. Specifically, we conclude that it's about a 21% decrease for being ugly. Now above average, while we get a 4.5% decrease in wages, we do the null hypothesis that that number equals 0. We fail to reject and conclude that there's no difference in wages of an above average person compared to an average person. And now you know the economics of ugly.